Taylor polynomial generalizations, what you're going to do is you'll either be given a Taylor polynomial or you'll be asked to generate one, and then you'll need to generate the term with the nth term. All right, so that's why we have an n here, and we didn't say degree 3 or degree 4 or whatever, or fifth term. What?
Like that's just like speaking in generalities.
Yeah. So basically the formula you generate is going to generate any term. If you plug n equals 1 in, it'll give you the first term. Okay, so, okay. What's natural log at 1? Awesome. All right, now the derivative. Yeah. Derivative at 1. Hope you can do that. Second derivative. Have you got that pattern down yet? Get 1 over x, then negative 1 over x squared, then 2 over x cubed will be the next one. Negative 1. Okay. This might be far enough. Let's see, that would be 2 over x cubed, right? Okay. We'll see. So generate the Taylor polynomial. Ooh, 0. Yay. You can write it in there if you want, but you don't have to. We might need another term. Generalize that. I think we will. Okay. Okay. It's usually helpful to simplify these to see the patterns. So basically what we're doing is generating the nth term. Okay. So let's see, this is x, right? Minus a half x plus 1 squared plus 1/3 x plus 1 cubed minus, is that a fourth? Oh, hallelujah. This is looking better every day. That's ugly. Okay, so the question here is, can you find a pattern? Plus 1. Okay, so first term, first power, right? Okay. 1 over 1, 1 over 2, 1 over 3, 1 over 4. Okay, so yeah, we're starting to see. And then this is going to be x plus 1 to the nth, right? Anybody know how to deal with the sign change? If it's even, it's negative, right? So there are two options for this is an alternating Taylor polynomial. You always have a -1 in there. It's either to the nth power or to the 2nth power. The 2n makes it's got to be 2n. No, that's not right. Something isn't right. Okay, if I put n there, the first term will be negative, right? If I put 2n there, the first term turns positive because it's -1 squared. The second term, okay, how are we going to deal with that? It's not 2n. What? That wouldn't make the alternating terms. Second term is negative. Think this through. I don't know why I'm stuck on this. It's not 2n. What it's? Yeah, I guess it would. So the first term would be squared, the second term would be cubed. Yeah, that works. We can do that. Well done. Sometimes you can put n-1 here. Your book has n-1. Who cares, right? Doesn't matter. Let's make sure that's right. Okay, I think we're good. All right, so that would be a generalization for that Taylor polynomial right there. Okay.
So we're just finding the pattern.
Yeah, you're basically just finding the patterns and writing out a general way. So if I plug 1 in, it's going to give me the first term, right? 2 in, it gives me the second term. Okay. Okay. So another polynomial Taylor, and then the generalizations right there. These can get pretty difficult thinking through them. I struggle with them myself, so that's really an introduction for you. Okay. Let's try another one. Let's do the Maclaurin polynomial of cosine. Did we do that yesterday? Down for it. I don't think it is.
Foreign for E.
Oh, it was E.
Yeah.
What are we centered at?
0.
Yeah, 0, right? So implication here, remember A equals 0. Okay. F at 0 is 1, right? All right, what's this derivative? Negative. Is that right? Okay. 0. So that means that this term is not going to exist in our polynomial, right? Because the multiplier is 0. negative cosine, -1, right? What's the third derivative? Sine. And again, so every odd term is not going to exist. Okay. Cosine.
Why is it that only the odd terms? Because they're zeros.
Hey Daryl, could you check the back doors and see if they're locked? One of the students said they were unlocked.
Sorry. Thanks, Daryl.
You can do it here.
Okay, so what's our polynomial centered at 0? Okay, that's 0, correct? Do you want to write it out? Or are you okay without writing it out? Okay, so that's nothing. So this one comes in here. -1 x plus 0 squared 2 factorial, right? And then this one, 0. Do you understand, Kenyon, why that's 0?
Why
Yeah, why these are, this first term doesn't exist? You asked that a few minutes ago.
I kind of understand it.
Okay, if I write this out, it's 0 times x plus 0, the first.
Okay, so because it's 0 multiplied by...
It's just 0, yeah. Yeah. So if you recognize that, if that derivative output is 0, you're good to go. Okay.
So it would be like that for every function, just this one?
It'll happen with a lot of them. Cosine zeroes out the odd derivatives. Sine zeroes out the even derivatives. Right, so, yeah.
But is it just with trig functions, or is it with other...
Okay, think. First, let me write. This is the fourth. Okay. I think so. We have a... Yeah, I think so. All right. So that comes from here. Simplify. Can you write a generalization for that? Question. Okay, so it's first we need to recognize the 0th term, which is this one, right, is the same as the first term. Right. So the Taylor polynomial degree 0 is the same as the degree 1 polynomial, just 1, correct? Because there's nothing here.
That's a degree 1 polynomial here.
The degree 1 polynomial is just 1 because it's because of that.
Oh, okay,
Right.
I get what you're saying.
It doesn't add anything. What about the degree 2 and 3? Are they the same? Yeah. So when you see a pattern like this, what you're probably going to end up doing is writing your Taylor polynomial like this. Okay. Because it's every term doubles, right? Okay. This is the same as this term, right? The next term up. Those are the same. Right, so you can note that if you want to. Your book does it this way, noting that these are the same. All right. So the question would be, okay, we have an alternating series, right, or polynomial. Is it to the n? Nope, we can do n minus 1. Oops. Or is it n plus 1? 0. If I plug in 2, yep. Okay, so that should work for the alternating part, right? What about the fraction? It is a factorial, I bet.
Or is it 2n because, yeah, 2n.
Yep.
Let's just do x equals 2n over 2n factorial.
Is it 2n? This Cade, right? We just said. So if it's the second term, T4 gets up, if it's n is 2, T4 1 over 4 factorial x to the 4th.
Oh, I see.
Yeah. I think he's right. Well done. I think you're better than me at this already.
If you put it into Cosine, this is a lot like code.
It's a lot like what?
It's like the same.
Yeah,
thought
this is
process.
very useful in coding. We said like yesterday I said I think there's some computer applications and I didn't think about generalizations. Yeah.
Yeah, we did do a lot of that.
Okay. There you go. So those are generalizations. You might have to write one on the AP exam. You might not. I don't know. It's kind of variable there. Okay. We're good? Yeah, like I said, give those your best shot. Like you can see me thinking through them and struggling a little bit. So,
I'm gonna have to take a nap, Mr. Osborne.
have to?
Yes. I'm a kid, I'm not gonna take a nap.
I will not be responsible for what might or might not happen to you while you are sleeping.
That's a permanent marker. Do you not take responsibility because you will be making any actions, or?
I won't be claiming any actions that I might or might not take.
I'm suspecting that to be the answer. 18 through 23.
Yeah.
You sure there's not an O next to that one?
I'm pretty sure I'm looking at it and there's no O next to it.
Alright. I guess that was not terrible.
Oop, somebody beat you to it.
It's only 8-12.
You're going to get really fast at these.